Hello everyone, this is Fahim from Exam Essentials, and today our main objective is going to solve this paper from October-November 2024 examination series, and our paper today is going to be Chemistry P1, right? So without wasting any more time, let's just get started. Question number 1. The three states of matter are solid, liquid, and gases. Substances can change from one state to another. The box includes some words about changes of state. Complete the table by giving correct word from the box for each change of state. You may use each word once or more than once or not at all, right? So before we get on to this question, let's just teach you something, right? So whenever we have a solid and we convert it into a liquid, the process is what we refer to as melting. And from liquid to gas, the process is what we refer to as boiling or evaporation. And from gas to liquid, the process is what we refer to as condensation or condensing. And from liquid to solid, the process is what we refer to as freezing, right? And from solid to gas, the process is what we refer to as sublimation. And from gas to solid, the process is referred to as deposition, right? So let's just take a look at this. From liquid to solid, right? From liquid to solid, from we have our liquid to solid, right? This is going to be freezing, so yeah, select up freezing from here. Then from gas to liquid, right, that is going to be condensing, so here it is that. And from solid to gas, the direct procedure, so what we refer to this as sublimation, right? So select sublimation from here. So let's just move on to the next part of this question. The diagram shows two states of matter, solid, liquid, and gas, right? Complete the diagram by drawing 6 circles to represent the atoms in the gas state, right? So there you should be drawing 6 atoms of this, right? And you have to ensure that the gaps between these 6 atoms are large enough, right? Because in gas the particles moves in random directions, right? So the spacing between each of these atoms needs to be larger than in solids and then in liquids and in solids, right? So yeah, let's just move on to the next question. Which statement is correct about this substance? The atoms move randomly in gas, right? As I said that in gaseous states, the atoms move randomly, right? Randomly at high speeds in random directions, right? So yeah, A is going to be the answer. Let's just check other answers as well. The atoms move randomly. No, they move by vibrating around in fixed position in their solid state. They just vibrate. The atoms are fixed in gas state. No, the atoms aren't. The atoms are moving over each other. Like the atoms are moving, right? And the atoms are in fixed position in liquid state. Well, not really. The atoms are sliding over each other in liquid state, right? So complete the equation by adding state symbols for the conversion of water into ice, right? So initially water is a solid, right? Sorry, for initially water is a liquid, right? Water is initially in a liquid state, right? And when it gets converted into an ice, it becomes a solid, right? So it should be liquid to solid. So yeah, that brings us to the end of question 1. Let's just move to the next question. Table 2, right? Table 2. We have some of the gases over here and there its formula, and we have the boiling points over here as well, right? Use gases from the table to answer these questions, right? You may use each gas once, more than once, or not at all. Name the gas needed for combustion. So for anything related to combustion, you need oxygen, right? You need oxygen to burn something, right? And the process of burning something in oxygen is what we refer to as combustion. Name the gas that is most abundant in the air. So yeah, that is going to be nitrogen, because nitrogen occupies approximately, I forgot the exact percentage, but that is going to be nitrogen first of all, right? Then green, then oxygen, then other gases such as argon, and yeah, there is this proportion of carbon dioxide as well, right? So yeah, that is going to be nitrogen. Name the gas that can bleach damp litmus paper, right? So that is going to be chlorine. So it is a test for chlorine gases as well, right? It bleaches damp red litmus paper to form white paper, right? So explain why hydrogen chloride is classified as a compound, right? Hydrogen chloride is classified as a compound. First thing is that it has different atoms, right? Hydrogen and Cl, right? Hydrogen and chlorine, right? So it has different atoms, right? And the thing is that they are bonded together, right? And they are chemically bonded together. So HCl has different atoms that are chemically bonded together, and this is what we refer to as a compound. So it comprises of atoms of different elements that are chemically bonded together in a fixed ratio. You can also say that in a fixed ratio. I mean, you can also refer to this as well, right? In a fixed ratio means that there is one hydrogen and one chlorine only, right? It has a fixed ratio. It is an H2Cl2, right? It is fixed, that is HCl. So moving on, why does chlorine have the highest boiling point, right? So why does chlorine have the highest boiling point? Let's just check this. Chlorine has the strongest covalent bond between its atom. Unfortunately, no. Chlorine isn't. Chlorine doesn't have strong covalent bond between its atom. Chlorine has strong covalent bonds between its molecule. No, between its molecule, chlorine, like this is Cl2, right, and this is another Cl2, right? This in between this, it has weak intermolecular forces of attraction, right? Not strong covalent bonds. Chlorine has strongest ionic bonds. Definitely not. It is not an ionic compound. It is a covalent compound, a simple covalent compound, right? Chlorine has the strongest force of attraction between the molecules, right? So this is gonna be the thing. This is gonna be chlorine. This is gonna be one chlorine. This is gonna be the other chlorine, right? The intermolecular force of attraction between them is the strongest, right? And as it is the strongest, it requires more heat energy to overcome this strong force of attraction to separate these two chlorine gases, right? Right, and hence we have D as our answer. Chlorine has the strongest force of attraction between the molecules. So yeah, let's just move on to the next question. This question is about the rusting of ions, right? So name two substances that are needed for iron to rust. So two substances are gonna be water and oxygen, right? Iron rust in the presence of water and oxygen. So yeah, water and oxygen. Give the chemical name for rust. That is going to be hydrated iron 3 oxide, or Fe2O3.xH2O, right? This is the chemical formula of it, right? But as I said, asked for the name, so that is going to be hydrated iron 3 oxide. So the two method shows the diagram shows two methods used to prevent iron from rusting. Okay, method A and method B. Method A will work if the paint coating is not scratched, and method B will work even if the paint coating is scratched, right? So explain how method A prevents the iron from rusting. So basically, you have applied a paint layer, right? You have applied a paint layer around the iron over here, right? And basically, what you have done is you have dipped the iron in zinc, right? You have basically dipped this iron in zinc, right? And this thing is what we refer to as galvanization, right? And this is nothing but forming a barrier between the iron and the environment, right? So basically, this paint over here acts as a barrier, right, and prevents the contact of this iron with water and oxygen from the environment, right, and prevents it from rusting. So that is what I've written over here. Acts as a barrier and prevents the contact of iron to water and oxygen, right? Moving on to the next part, give the name of method B. As I said, galvanizing or galvanization. So explain how method B prevents iron from rusting even when zinc coating is scratched, right? So basically, zinc is a more reactive metal than iron, and the more reactive metals has a tendency to lose the electrons, right? And the loser of electron or the loss of electron is what we refer to as oxidation, right? So the zinc will get oxidized instead of iron, right? The zinc is gonna lose the electrons instead of iron, right? And hence this is how zinc is going to prevent the iron from rusting. So yeah, zinc is more reactive than iron and gets oxidized instead of iron, right? So always remember that a more reactive metal, the more reactive a metal is, the greater tendency it has to lose its electron, right? So yeah, let's just move on to the next question. Question 3. A student does an experiment to identify dyes in inks A, B, C, D, E. So these are the inks. So I can easily get an idea that this is going to be a chromatography experiment, because they are going to identify the dyes in a ink, right? So basically they are going to separate the components of these inks. The student uses this apparatus: a chromatography paper, a beaker, a solvent, inks, ABCD. Describe how the student should set up the apparatus and the experiment, right? You may use a diagram as well, right? So for this type of 5-mark questions, I would basically first of all draw a diagram, right? Because when you draw up these diagrams, you do not need to explain word by word, right? You could just say this in your diagrams, right? So basically, this is the chromatography paper, this is the solvent, this is the beaker, these are the inks, right? Now this is the solvent front, and this is the baseline that should be drawn with a pencil, and the baseline should be above the solvent, right? Because otherwise the baseline would dissolve in this solvent, right? The baseline may dissolve in this solvent, right? So basically, to prevent that, we have to ensure that the baseline is above the solvent, right? So yeah, I have indicated that over here in my diagram. So yeah, I do not need to write write that up. This is the chromatography paper, and the baseline should always be drawn with a pencil, because if it was drawn with a pen, then the pen have inks, right? And the inks are going to separate as well, right? And impact with the chromatography results, right? So basically, you have to draw it with a pencil, right? So I have already explained all of this in my diagram, so yeah, I basically do not need to repeat those again. So what I said is, dip the chromatography paper in the solvent, ensure that the baseline is above the solvent. I have written that down over here. So I mean, I wouldn't need to have written that because I've already showed it in my diagram, but yeah, let's just go with it. And remove the paper as the solvent front reaches near the edge of the paper, right? So you have to remove the paper from the solvent, right, as the solvent front reaches the end of the paper, right? This is the end of the paper, this is the solvent front, right? And when the solvent front reaches this level, you have to take the paper out of the solvent, right? So yeah, more or less that was it. Let's just move on. The chromatogram shows the results for the ink A, B, C, D, E. Okay, explain which ink contains a dye that is insoluble, right? So that is going to be E, because E doesn't move up the chromatography paper, or it doesn't travels up the chromatography paper. So E is going to be our answer. I've written that over here, ink E, as it doesn't move up through the chromatography paper. Moving on to the next question, explain which inks contains the same dye, right? So that's going to be ink A and ink C, because both of these dyes separates at the same level, right? Or both of these dyes, both of these dyes travel the same distance from the start line or from the baseline. This is going to be baseline or start line, right? As both of these inks travels the same distance from the baseline, these dyes are going to be the same as well. Which ink contains the same dye? That's going to be A and C, as both inks travel similar distances from the baseline or start line, right? Moving on to the next part of this question. Describe how the student could use this chromatogram to determine the RF value of the dye in ink C, right? So how you are going to determine the RF value, right? So to calculate the RF value, first of all, you have to determine the distance that this ink has moved from the start line or baseline, right? You have to calculate this distance, assume this distance to be d1, right? Also, you have to calculate the distance of the solvent from the baseline as well, or from the start line. You have to calculate this distance as well, right? Assume this is d2, right? And once you have this two distance, what you are going to do is you have to divide d1 by d2 to calculate the RF value, right? So yeah, that is what I have written over here in my answer. Measure the distance traveled by ink C from the baseline or start line. Measure the distance of the solvent front from the baseline. Use the formula to calculate the RF value. RF value is going to be distance moved by the ink divided by distance traveled by the solvent front. So yeah, let's just move on to the next question. Question 5. Hydrogen peroxide decomposes to form water and oxygen. The decomposition is shown in the equation over here. Give a test for oxygen gas, right? So for test for oxygen gas is going to be your insert a glowing splint, right? You can see clearly that it is glowing, right? And if there is oxygen over there, then it is gonna relight. The glowing splint is gonna relight, right? Like it is gonna catch a fire, right? So the test for oxygen gas is gonna be insert a glowing splint, and the positive result is that it relights. But here you only have to mention about the test, right? Because it doesn't say anything about the results and so on, right? So describe the rate of reaction is increased. Describe why the rate of reaction is increased by adding a suitable catalyst, right? Describe the rate of reaction is increased by adding a suitable catalyst. Describe how a catalyst increases the rate of reaction, right? So basically, let me just give you an analogy, right? So assume that there are there is this there is this something at A, right? And there's this another thing at B, right? Now a person wants to go from A to B, right? But the thing is that while the person is trying to go from A to B, there is gonna be some obstacle, right? That is gonna be, suppose, X, right? So for a person to get to B, the person needs to first go to X, and once it gets to X, this is gonna be, then the person can travel to B, right? So I mean, this thing or this procedure is gonna take up both time and energy, right? So suppose there is a shortcut between between these two routes, right? A and B, right? This shortcut route, right? So a catalyst does this same thing. A catalyst gives an alternate route that requires the minimum amount of that requires less activation energy, right? So provides an alternate route a catalyst provides an alternate route that requires less activation energy. As a result, a greater proportion of the particle have the minimum energy to react, right? Because they are going to provide an alternate route that requires less activation energy. So yeah, let's just move on. A student uses this apparatus to investigate the rate of decomposition of hydrogen peroxide solution. Okay, catalyst solution, and this is the volume of oxygen being collected in a syringe, gas syringe, and this is gonna be a conical flask. So yeah, a student adds 100 centimeter cube of hydrogen peroxide solution at 20 degrees Celsius to the apparatus labeled as A. The student records the total volume of oxygen gas collected every minute for 16 minutes. The diagram shows the result, right? So yeah, name the piece of apparatus labeled as A and B, right? A is going to be the conical flux and B is going to be syringe, as I said, or gas syringe. Determine the volume of oxygen produced in the first 4 minutes, right? The volume of oxygen produced in the first 4 minutes is going to be 38, right? Because each of these individual small boxes is equivalent to 2, right? So this is going to be 30, 32, 4, 6, 8. So that is going to be 38 centimeter cube. Determine the rate of reaction at 8 minutes by drawing a suitable tangent to the curve, right? So rate of reaction at 8 minutes. This is 8, and yeah, a tangent should needs to be drawn from here to here, right? And once you have your tangent, you are gonna select the two y coordinates and two x coordinates, right? And I mean, you could do this on random. I mean, this is completely on to you, right? Basically, I have selected this to be my y2, and this to be my y1, and this to be my x2, and this to be my x1, right? And once I have these coordinates, I could easily find the gradient, right? Del m, okay, or like m, right? M equals to y2 minus y1 by x2 minus x1, and once I plug it into this equation of m, I'm gonna get the gradient, right? And the gradient corresponds to this rate, right? Now the thing is, how do you figure out the unit, right? So to figure out the unit, assume that delta y by delta x, right? In y-axis it is in centimeter cube, and in x-axis it is in minutes, right? So the unit is gonna be centimeter cube per minute, right? So this is gonna be the unit. So let's just move on. Rate is equivalent to gradient, and y2 minus y1 by x2 minus x1, and I get a gradient of 3.9 centimeter cube per second, right? So yeah, let's just move on. This question is about ionic and covalent compound. The table gives formula of some positive ions and some negative ions and some compounds containing these ions, okay? So NH4 reacting with Cl is going to be NH4Cl, Zn reacting with Cl2, Zn reacting with Cl is going to be ZnCl2, right? So why this is going to be ZnCl, right? Because Zn has a charge of +2 and Cl has a charge of -1, right? So this is going to get cross multiplied, right? So basically this is gonna get cross multiplied. Zn is going to come over here, and Cl minus -1 is going to go over there, right? So this becomes ZnCl2, right? So let me just repeat this up again. So basically, how does this formula comes, right? So you have a zinc charge on the zinc of +2 and chloride -1, right? Now the charges are gonna cross multiply. It is gonna come over here and it is gonna come over there, right? So forms ZnCl2, right? So yeah, I have done for each of the other stuff similarly. Al with reacting with Cl minus is gonna form LCl3. Zn with SO4 2 minus is gonna form ZnSO4, because this plus 2 and minus 2 is gonna cancel out each other, and NH4 reacting with this is gonna for NH4 3 and N, because this is again gonna get cross multiplied, and Zn on right, and this is the thing. Give the name of the compound Al2SO4 3, right? So this is gonna be ammonium sulfate. Ammonium sulfate. Right, the diagram shows our arrangement of electrons in atom of magnesium and an atom of chlorine. Alright, describe in terms of electron what happens when magnesium atoms and chlorine atoms form magnesium chloride, which is an ionic compound, right? So how many electrons are in the outer shell of chlorine? 1, 2, 3, 4, 5, 6, 7, 8, which means that a chlorine needs to have one more electron to form an noble gas configuration, right? To have 8 electrons in the outer shells, right? And how many electrons does magnesium has? It has 2 electrons in its outer shell, right? So one of this electron is going to come over here, right? And then there needs to be another chlorine atom, and the another chlorine atom needs to gain this other electron, right? So yeah, this is more or less what you have to describe over here. Magnesium loses 2 electrons to form Mg2 plus. Each of the electron is gained by 2 Cl. This leads to the formation of MgCl2, which is an ionic compound. Moving on to the next part of the question, you have to basically complete the dot and cross diagram. So yeah, there are 5 electrons in the outer shell of nitrogen, right? So put 5 electrons, 1, 2, 3, 4, 5, right? You have 5 electrons, right? The outer shell of nitrogen, right? Now hydrogen can only donate 1 electron, right? So you fill the hydrogen electrons as well, right? And yeah, this is how you have a diagram of a covalent bond. Describe the forces of attraction in a covalent bond, right? The forces of attraction is gonna be, there is electrostatic forces of attraction between this shared pair of electrons and the nucleus, which means that the nucleus of nitrogen and the nucleus of hydrogen, and this together is what we refer to as nucleus. This is the plural form, right? Not nucleus. Nucleus means the singular form, right? So there is gonna be an electrostatic force of attraction between the shared pair of electrons and the nuclei, right? And that is the definition of covalent bond. So yeah, there are electrostatic forces of attraction between the nuclei and the shared pair of electrons, right? So yeah, moving on to the next question. Give me a moment, guys. Magnesium sulfate crystals have the formula of this. Okay, a student uses this apparatus to heat tube A and collect water of crystallization in tube B. Okay, so you have the magnesium sulfate crystal over here, and you are heating it, right? And the water is gonna evaporate, right? Or the water is gonna form water vapors, and the water vapors come over here, and once it is here, it is gonna get condensed because of this acid and forms this water liquid. The student records the mass of tube B at the start of the experiment, and every minute for 6 minutes, right? So this is the initial mass, and this is the mass after 6 minutes, right? Give a reason why the student surrounds the tube B with ice, right? As I said, ice is needed to convert this water vapor into liquid water, right? So, and to prevent the water vapor from escaping, to condense H2O gas into H2O liquid, right? H2O gas basically means water vapor. Student how the student knows that when all of the water of crystallization has been given off, right? So basically there won't be any change in the mass of the tube, mass of tube B, right? The mass of tube B remains constant or the same, right? It means that all of the water has been given off. No further change in mass of tube B, right? So describe a chemical test that a student could use to show that the liquid in B was water, right? So what you could do is you could add cobalt to chloride, right? Anhydrous cobalt to chloride, right? And if you add anhydrous cobalt to chloride, it is gonna turn pink. Or you can add anhydrous copper to sulfate. and if you add this, this is going to turn blue, right, in the presence of water. So yeah, more or less I have written that over here. Add anhydrous cobalt to chloride, the color changes to pink. You could also add copper to sulfate and the color changes to blue, right? The initial color should be white and the color change should be to blue with copper to sulfate, and with cobalt to chloride, the color is going to be initially blue and it is going to turn to pink, right? The decomposition of hydrated magnesium sulfate is shown in the equation. This is the decomposition of the reaction. At the end of the reaction, mass of MgSO4 remaining in the tube is 6 grams. So you have the mass of this, right? Using this mass and the result, calculate the value of X, right? So basically you have to find the value of this, right? And once you have the value of this, then you know the value of this X over here in this compound, right? So basically how you are going to do this, right? So basically you have the mass of this and also you have the AMR, right? So number of moles equals to mass by AMR, right? So basically you could find the moles of this, right? And then you are going to compare up the molar ratios of these two, and they are in a 1-to-1 ratio. If this is 1 and this is X, suppose this is 2 moles, right? Suppose this is 2 moles, right? So the other thing is this one should be 2x, right? Comparing molar ratios, right? If you are facing problems in these questions, in these questions to identify the molar ratios and everything, right, make sure to comment below, right? Because I have already pre-assumed that you guys have a basic understanding of this, which you should do at this point, right? So yeah, if you are facing problems in this, make sure to comment below so that I could know that you are facing problems in this stuff, so that I can make up separate videos, or you can join our crash courses as well, right, where I will be going through all of these stuffs that you need to have, all of these stuff that you need to know basically for your IGCSE exams, right? So yeah, without wasting any more time, let's just try to find this out, right? So once we have this, suppose the moles of this is, assume the moles of this is 7x, right? Then how do you find the moles of water? Moles of water equals to mass by molar mass, right? And basically we know the mass of water, right? How do you know the mass of water? The mass of the tube B, when time equals to 0, this is the mass of the tube, which means that this is the mass of the tube only, right? Because the reaction at time equals to 0 didn't started, right? So this is the mass of the tube only, right? So if you subtract this mass of the tube individually from the mass of the tube plus water, then you only remain with mass of water, right? So suppose mass of tube plus water minus mass of tube. So this mass and mass gets cancelled out, and what you are left is with water only, right? So if you subtract this 15.8 from 22.1, you are gonna get the mass of water, right? So yeah, and if you have the mass of water, and the AMR is also given over here, you could easily equate this thing and solve for the value of X, right? And once you have the value of X, you could also find the X in this compound as well, X over here as well, right? X in this compound. So yeah, more or less that is what I've done over here. So let's just take a look. 6 divided by 120 gives us a mole of magnesium sulfate, that is 0.05, and the moles of water is going to be this times this, right? And the moles of water is going to be mass by molar mass, so this by this, and when you solve this, get a value of 7, right? And this is the mass of water, that comes to 6.3, right? 15.8, 22.1 minus 15.8 comes to 16.3, right? So yeah, moving on to the next question. A student uses this apparatus to investigate the rate of reaction between marble, that is calcium carbonate, and dilute hydrochloric acid, right? So give a reason why the reading on the balance decreases during this reaction. So right, during this reaction, carbon dioxide is produced, right? And carbon dioxide escapes through this apparatus, right, or leaves the apparatus, right? And this causes the mass to decrease. Carbon dioxide produced escapes from the apparatus. Explain why rate of reaction is greatest at the start, right? Because at the start you have the highest concentration or amount of this HCl, right? So yeah, rate of reaction is the greatest as well. Concentration of HCl is the greatest, hence the Hence, there are more frequent collisions, right? The frequency of collision increases or the collision increases, right? Because there are more reactants at the start of the reaction, right? So there should be more frequent collisions as well. After 10 minutes, the reaction stops even though there are marble chips remaining, right? Because all of the ACL gets used up, right? And all of the ACL, if it gets used up, it doesn't react with this calcium carbonate, right? And once it doesn't react with this calcium carbonate, it shouldn't produce this and this, right? So all of the ACL gets used up. This is what I've written over here. All of the ACL gets used up. ACL aqueous means hydrochloric acid. The student repeats this experiment with hydrochloric acid at a higher temperature to investigate the effect of the rate of reaction. Okay, give two variables that the student should control to make sure that the results are valid. Okay, so first thing is that the student has increased the temperature, right? But the experiment is the same. So basically, the surface area of this marble chips needs to be the same as well. And also, since the student is only increasing the temperature, the concentration of HCl needs to be constant as well, right? Because if the concentration of this thing increases, then the rate is going to increase or decrease as well, right? So yeah, size of the marble chips or the surface area of this, and the concentration of hydrochloric acid. Explain the effects of increasing temperature of hydrochloric acid on the rate of reaction, right? So basically, whenever the temperature increases, the kinetic energy of the particles in the reaction involved increases as well, right? And also, as the temperature increases, a greater number of the particle has the minimum energy to react, right? So as the temperature would increase, they would have the minimum, or a greater proportion of the particles would have this minimum energy to react if the temperature increases, right? So yeah, and hence the rate of reaction increases as well. So that is what I have written over here. As temperature increases, kinetic energy of the particles increases as well, frequency of collisions increases, and a greater proportion of the particles has the minimum energy to react, and hence the rate of reaction increases as well. So basically, this is a common question that generally appears in your IGCSE chemistry paper 1. So yeah, if you write these points, you're gonna get 3 out of 3 marks, right? So I highly suggest you all to have understanding of this, and basically, if possible, memorize this thing, right? Because it isn't that tough. And yeah.
Hi, are you an October 2025 O level candidate? Your exams are just 4 months away, but you are still feeling stuck. Still doing classes, watching YouTube, but no real improvement, right? You are not alone, and it's not your fault. It's the method. Let's fix it. Welcome to Exam Essentials, where every second counts and every session delivers. We are launching the High Impact Crash Course October 2025, designed for both Edexcel and Cambridge students. The High Impact Crash Course will start from 10th July. Until 13th August, we'll be covering the syllabus in detail for each and every subject. And right after the end of a chapter, you guys will be doing the Exam Essentials Premium Mega Revision Worksheet, which will allow you guys to get familiar with the recent question papers. And in the month of September, we will be doing extensive paper solving, the past papers, from the year June 2019 to October 2025. Now, you guys might be saying, Sir, I face a lot of difficulties whenever I solve a question paper. Don't worry, dear. In the month of October, our teachers will be having one-to-one sessions with each and every one of you guys to solve your personal problems regarding the question paper or even the syllabus. And after the problem solving sessions, you guys will be giving mock exams. And our mock exams, along with the feedback, are absolutely free for our students. And not only this high impact crash course also includes 20 plus question paper solving videos for each and every subject. There will be digital notes, worksheets, and we will be providing you the recorded sessions of each and every live classes that you guys can rewatch anytime. And all the teachers will be available 24 hours, 7 days to clear your doubts. Stop guessing, stop panicking, start learning the way toppers do. Now, you guys might also be thinking, what are the results of our previous students? The results of our previous students are extremely good. They have done very well. So, without wasting any more time, sign up now and gear up for success with the ultimate O level crash course. Message us on our Facebook page Exam Essentials or WhatsApp us at the number provided in the description box, or you can see the WhatsApp number right here. Book your first trial class. Your top grade is still possible. Start today.
Moving on to question number 9. A student uses this apparatus to investigate the heat energy released when a liquid fuel burns. Okay. This is the methodology. Measure the mass of the spirit burner and the fuel. Okay, fuel. Add 100 grams of water to the aluminum can. Measure the temperature of the water. Measure the new mass of the spirit burner and the fuel. Right. Okay. Give a reason why the student uses an aluminum can rather than a glass beaker, because the aluminum can or the aluminum itself is a good conductor of heat, right? So yeah, aluminum is a good conductor of heat or a better conductor of heat, right? You have to show the comparison between why you're using this aluminum can and this glass beaker, right? Explain when the fuel burns, a black solid forms on the aluminum can, right? Identify this black solid, so that is going to be carbon or soot, right? And why is that from? Due to incomplete combustion reactions. Due to incomplete combustion reaction. I mean, honestly, if you do up these papers, you'll see that these papers are extremely good to revise these topics up, right? So whenever you're doing up these papers, you're simultaneously revising the topics as well, right? I mean, whenever doing this experiment, think kind of differently, right? The person could have used the lid to cover this to prevent heat from escaping, right? So yeah, like this. Show that heat energy needed to raise the temperature of 100 gram of water by 50 degrees Celsius is approximately this, right? So energy, how do you find that? Q equals to AMC del T, right? You have del T, that is 50, you have mass of water, that is 100, and you have C, that is 4.2, right? So you're going to equate this into the equation and get a value that should be approximately or around 20,000, right? So I have done that and I get a value of 21,000 joules, that is approximately 20,000, right? So yeah, moving on to the next question. The student burns 1.8 gram of ethanol. The formula of this ethanol is C2H5OH, right? Let me just write this down. Formula of ethanol is C2H5OH, right? CnH2n plus 1 OH. This is the formula, general formula of alcohol, right? So suppose C is 2, then H is gonna be 2 to 4 and 5 OH, right? So yeah, this is how I instantly understood that this should be the formula of ethanol. So yeah, calculate delta H, right? So delta H is what, right? I'm going to figure how do I calculate delta H from the units, right? Delta H is minus kilojoule per mole, right? And what is kilojoule? It is a measure of a unit for energy, right? So something, it should be Q divided by moles of something, right? When you divide Q by moles, you're going to get energy divided by moles, right? So you have the energy that is 21,000 joules. You basically need to convert it into kilojoules. So how do you do that? You divide these joules by 1000, right, to get the energy in kilojoules and the moles of it, right? So basically, you know the mass of this ethanol, and the molar mass should be 12 times 2, that for carbon, plus 1 times 5 for hydrogen, and for oxygen it is going to be 16 plus 1, right? So yeah, that is how you're going to do this. And obviously do not forget to include your minus sign, right? Negative sign. So yeah, I have basically done that. Q is this kilojoule, N of ethanol is this, and delta H is kilojoule per mole. 21 divided by 0.04, that is minus 525 kilojoule per mole. Do not forget to include this sign, right? So moving on, In a different experiment, the student burns 3.7 grams of butanol. Okay, this is an equation for the incomplete combustion of butanol, right? So complete the equation. So let's just see how many oxygen we have over here. We have 4, 5, 6. We have 11 oxygen over here, right? And how many oxygen we have over there here? It is 2 and 1, right? We have 2 and 1, 3 oxygen over here. So if I add a 5, then I should be getting 10 oxygens. I should be getting 10 oxygens over here, plus that 1 oxygen gives us a total of 11 oxygen, right? So oxygen on the left hand side and the right hand side balances out, right? So let's just move on to the next question. Calculate the total amount in moles of volumes of gas produced in this incomplete combustion, right? So you have this butanol, right? You could easily find out the moles of it, right? So the formula of this formula for butanol is C4 2n plus 1, right? That is going to be 9 OH, right? So this should be MR of this should be 12 times 4 plus 1 times 9 plus 16 plus 1, right? The MR should be 74. Once you have the MR, what you could do is you could calculate the moles of this, right? And once you have the moles of this, you can find the moles of this using these molar ratios, right? So this is 1 and this is 2, right? So suppose this is, if this is gonna be, so suppose if the mole of this is gonna be 2, then the mole of this should be 10, right? Why 2 times 5? So why 2 times 5, right? Because many of the students have this question. So what I used to do was, suppose 1 is representing 2, right? So unitary method. So 1 mole, right? 1 mole of this represents 2, so there are 2 moles, right? So 2 moles should represent what, right? So 2 moles should represent 2 times 2, right? This should be 4. Let me repeat again. Suppose 1 mole, right? So 1 mole of beta, so 1 mole of this represents a certain amount, right? Certain mole, right? So 2 moles of this should represent what? 2 times 2, 4, right? So if you are facing in problems in these questions, I have said earlier, make sure to comment below, because this is a really important concept that you have to build up from now, so that you could utilize this in your A levels as well, right? Because this thing is going to get intense in your A level exams. So I have found the moles of butanol, and the moles of carbon dioxide is going to be times 2, moles of carbon monoxide is going to be 2, and the moles of water should be times 5, right? So yeah, that is how I have found the moles of this, moles of this, moles of this. And once I have the moles of all of this, what I did was I combined all of this mole to find the total moles, and once I combine these moles, I get 0.45. I believe that is what, yeah, total amount of moles. Okay, let's just move on, guys. Give me a moment before we move on. Give me a moment. All right, so moving on to the next part of the question. Next question. This question is about alkanes and alkenes, ethane and ethene. This is an alkane and this is an alkene. So how did I understand it from the name, right? ANE is the suffix of alkanes, and ENE is the suffix of alkenes. ENE, right? Reacts with bromine, but under different conditions, right? Give a reason why ethane does not undergo addition reaction, right? Because ethane does not have any carbon-carbon double bonds, right? And for addition reactions to take place, there needs to be a carbon-carbon double bond. The carbon-carbon double bond needs to be eliminated, right? And once it gets eliminated, carbon has 3 spots around it, right? So one of the bromine could join over here and the other bromine could join over there, right? So yeah, move on. There is no carbon-carbon double bond. Complete the equation for the substitution of ethane and bromine, including essential conditions for this reaction, right? So this is gonna be a substitution reaction in your level, and it is gonna require a UV light or ultraviolet radiation, right? So the thing is that this one of the bromine is gonna displace this hydrogen, one of the hydrogen, right? And if one of the hydrogen gets displaced, this hydrogen is gonna form a bond, another bond with one of the bromine to form HBr and this, right? So basically, if I draw this, it should look something like this. You're going to learn this in your A levels and in your AS exam. So what happens is that one of this bromine takes the position of this, right? Takes the position of this, right? And hydrogen ion is replaced, right? So bromine attaches over here, right? And one of the hydrogen is replaced, right? However, we have one more bromine left over here as well. We have one more bromine left over here, right? So that displaced hydrogen plus this bromine forms HBr. Clear so far? So yeah, you don't need to go into this much details of this, but yeah, for the sake of explanation, I have done that. So yeah, you will like give the color change when ethene reacts with bromine, right? It should be brown, it should be orange to colorless. You should have this memorized by now. The diagram shows the displayed formula of two compounds in the homologous series of alkenes, okay, homologous series and so on. Compounds in the same homologous series have the same general formula, right? So what basically is this homologous series, right? It is basically a family of organic compounds, right? So what are the other characteristics of this homologous series? For an instance, they are going to have the same functional group, and apart from that they are going to differ by a CH2 group, right? So yeah, for 2 marks, 2 of these points should work. Similar functional group differs by CH2 group, right? So basically you should have this memorized by now. So yeah, moving on to explain why alkenes in the diagrams are isomers, right? Because they have the same molecular formula. Why? Because 1 2 3 4, we have 4 carbons, and 1 2 3 4 5 6 7 8, we have 8 hydrogen, right? For this one, let's just check for this one. 1 2 3 4 C4, 1 2 3 4 5 6 7 8, right? We have C4H8, we have C4H8 for this one as well, right? So the molecular formula for these and this is the same, right? But let's just take a look at the structure, right? The structural formula, we have a carbon carbon double bond over here, and we have a carbon carbon double bond over here, right? So the structural formula is different, right? Hence these are isomers. And these are what isomers? As the position of these functional groups are different and are in different location, these are positional isomers, right? So yeah, they have the same molecular formula but different structural formula, and they are positional isomers. Draw another displayed formula of another alkene that has the isomer, right? So I have gone with this one, CCC, and a branch of this methyl group, right? Branch of this methyl group. So yeah, this should be coming to you. You should be getting a grasp of it once you keep on practicing these structures, right? So the main thing that I would suggest you is to drop these structures to get a hang of it, right? So yeah, moving on to the next question. The reaction between polyethylene, the reaction to use make polyethylene, I mean those polyethylene bags could be represented by this equation, right? Describe the differences between the reactants and the products in this reaction, right? So first of all, this is the monomer and this is the polymer, right? The polyethylene is a solid, right? The product is a solid, whereas the reactant is the monomer is simple, so it is a monomer is a gas, right? One another difference is that in the monomer we have a carbon carbon double bond, whereas a carbon carbon single bond is present over here, right? So you could say that this is saturated and this is unsaturated. The product and the reactant. The product has no carbon carbon double bond or is saturated, and the reactant has carbon carbon double bond and is unsaturated, right? And how many differences do we have to write? We have to write 3, okay? And yeah, one more thing, you can say that the carbon carbon double bond is shorter for this and is longer for this, right? So why it is shorter, right? So assume a simple analogy, right? So there is the shared pair of electrons, right? So what I said, a covalent bond is the bond that has force of attraction between the shared pair of electrons and the nuclear, right? So as there are more electrons, the force of attraction between the shared pair of electrons and the nucleus is going to be greater, right? As a result, the bond is going to get shortened up, right? And this bond is even more shorter than this carbon carbon double bond, right? Because we have 3 pair of electrons, so the force of attraction between the nuclear and the shared pair of electrons should be greater, right? So the bond length for carbon carbon double bond should be smaller for the reactants, why it should be larger in or should be bigger in the products, right? So yeah, that is what I have written over here. Carbon carbon length is shorter for reactants than products. Carbon carbon double bond is present in reactants, whereas carbon carbon bond single bond is present in product is a solid, whereas the reactant is a gas, right? So yeah, this brings us to the end of question 10. Let's just move on to question 11, because a moment again. All right, so moving on. This question is about the reaction of some of the compounds of lead. Okay, lead can be extracted from lead to sulfide (PbS) by a two-stage reaction. Stage 1, lead sulfide is heated in air and reacts with oxygen to produce lead oxide and sulfur dioxide. And stage 2 is that lead to oxide is heated with carbon in a furnace. Okay, write a chemical equation for the reaction of stage 1, right? So lead sulfide (PbS) is reacting with oxygen to form lead oxide and sulfur dioxide. Lead sulfide with oxygen to form lead oxide and sulfur dioxide, right? You get 1 mark for this, right? And as it is a 2-mark question, you have to balance up this equation. So how many oxygen are over here? 1 and 2, right? So there are 3 oxygen over here, right? So 3 by 2, right? So what basically happens is that when you give this 3 by 2, this 3 by 2 and times this 2, right? This 2 and 2 cancels out, right? So what you have left is 3, right? So there is 3 oxygen over here and there is 3 oxygen over here as well, right? And if you do not want this in fraction, what you could do is you could multiply this everything by 2, right? And this 2 and this 2 would get cancelled out, and you will be having 2 PbS, 2 PbO and 2 SO2, right? So yeah. All right, moving on to the next question. Give a reason why sulfur dioxide should not be released into the atmosphere, right? So when sulfur dioxide is released into the atmosphere, it combines with water to form sulfurous acid, right? Acid is part of chemistry, and this causes acid rain. This causes acid rain, right? So yeah, combines with water to form sulfurous acid that leads to the formation of acid rain. For stage 2 of the reaction is that PbO plus carbon, Pb plus carbon dioxide, a mass of 892 tons of lead oxide, 892 tons of lead oxide is heated in a furnace with an excess of carbon. Calculate the maximum mass in tons of carbon dioxide that could be released into the atmosphere, right? So basically, find the moles of this, then find the moles of that, and then from the moles mass by molar mass, you have the molar mass of carbon dioxide. You could easily find the mass of this, right? So yeah, moles of this is gonna be, so first thing is that the mass is in tons, right? So what I'm gonna do is I'm gonna convert this mass into grams first of all, right? So unitary method, if 1 ton is 10 to the power 6, therefore we have 892 tons. So 892 equals to 892 into 10 to the power 6, right? So yeah, I have done that. So the moles of carbon dioxide is going to be half, right? Because the ratio is 2:1, right? So if 2% of something represent x, then 1% should be x by 2. Therefore 10% or 10 represents x by 2 times 10, right? So basically what I have done over here is this thing, right? So yeah, I have divided it by 2 to get the moles of carbon dioxide, and once I have the moles of carbon dioxide, I could easily find the mass. And the mass is number of moles times mass by MR, right? MR of carbon dioxide is 44, and I have the moles of carbon dioxide, so the mass is gonna be this, right? This is in grams. Now I have to convert this into tons. So how can I do that? I would easily divide this with 10 to the power 6 to convert this into tons, right? Because unitary method again, right? Unitary method. So let me just show you for students who aren't understanding this at this point. 10 to the power 6 represent 1 ton. Then 1 gram represents 1 by 10 to the power 6. Therefore 8.8 into 10 to the power 7 grams should be represented by 10 to the power 6. I mean, honestly, you should be having a hang of this, all of this by now, right? So if you aren't having, so you do understand, right, while you are at this course. So yeah, prepare yourself accordingly. The diagram shows the structure of lead sulfide and sulfur dioxide. You have your lead sulfide and sulfur dioxide. Explain in terms of bonding and structure why lead sulfide is a solid with a high melting point at room temperature, and why sulfur dioxide is a gas at room temperature, right? So first of all, this thing is an ionic compound, right? And as it is an ionic compound, it has strong electrostatic force of attraction between the positive and the negative, between the oppositely charged ions, right? And it requires a lot of energy to break these strong forces of attraction between these positive and negative ions, right? And hence it has a high melting point, and apart from that it is a solid, right? And for this thing, this is a simple covalent compound, and it has weak intermolecular forces between its molecules, right? So this is a molecule of sulfur dioxide, this is another molecule of sulfur dioxide, right? And it has this weak intermolecular forces between these molecules, and it requires less energy to overcome these weak intermolecular forces, right? And hence it has a low melting point and is a gas at room temperature. So yeah, let's just move on. For lead sulfide ionic compound, giant, stronger electrostatic force of attraction, oppositely charged ions. As a result, PBS has a high melting point and is a solid with lots of energy, and it requires a lot of energy to break these ionic bonds, right? So I have basically highlighted the marks. I have basically highlighted the important words that you need for this answer. For sulfur dioxide, simple covalent compound, weak intermolecular forces of attraction between the molecules, less energy is needed to overcome these weak intermolecular forces, and as a result sulfur dioxide is a gas at low melting temperature. Clear? So yeah, let's just move on. This is the last part of this question. A different oxide of lead contains 90.7% of mass by lead and 9.3 mass by oxygen, right? So basically all of that simple stuffs of calculating an empirical formula. PbNO, that is 90.7, that is 9.3, divided by mR of lead by mR of oxygen. You then divide the one that has the smallest value with by you divide the one that has the largest value with the one that has the smallest value, right? So out of these two, this is the smallest, right? So with the smallest value, I'm going to divide this and this as well, right? So I get a ratio of 1 to 1.3, right? Now this thing isn't a whole number, right? So what I'm going to try to do is I'm going to multiply this with 3, and once I multiply this with 3, I get 3 is to 3.9, right? And 3.9 is equivalent to 4, so I have Pb3O4, right, as the empirical formula. Let's just repeat this thing again. You have the percents, you divide it by the molar mass, that is 207.2 for lead and 16 for oxygen, right? And then you are going to divide all of these with the ones that has the smallest value. So in my case that was 0.438, so I divide this 0.438 by 0.438 and 0.581 by 0.438, so I get 1 to 1.3, right? Now this isn't a whole number, right? So how do I convert it into a whole number? I multiply this with 3 and this thing also with 3, right? So I get 3 is to 3.9, so 3.9 is approximately 4, so it should be PB3O4, right? All right, so that brings us to the end of this paper. If you are facing problems in any of these questions or the subject or in this subject especially, make sure to comment below. I will be more than glad to help you all. Have a great day. Thank you. And yeah, if you find this video to be helpful, then make sure to like, comment and subscribe. And yeah, have a great day. Good luck for your exams. Thank you.